Today we're on page 3 of our Chapter 6 notes packet, section 6.2, arithmetic sequences. In an arithmetic sequence, the difference between any consecutive terms is a constant. This is called the common difference, denoted by lowercase d. So lowercase d is equivalent to the difference of any two consecutive terms. So d would equal the second term subtract the first term, which would be the same as the third term subtract the second, or the fourth subtract the third, etc. To calculate a sub n, the nth term of an arithmetic sequence, with a sub 1, the first term, and d, the common difference, we use this explicit formula. The formula is a sub n, the nth term, is equal to a sub 1, the first term, plus d, the common difference, times n minus 1. Memorize this formula. You need to know this formula. So why don't we write it? All right, a sub n equals a1 plus d times n minus 1. You need to memorize this. Solving for d, if we were to take this formula and solve it for d, well, the first step would be to subtract a1 from both sides. So we would have an subtract a1 equals d times n minus 1, and then divide by n minus 1. And we have d is equal to a sub n minus a sub 1 divided by n minus 1. Identifying arithmetic sequences. Decide whether the sequence is arithmetic. If it is, find the common difference d. Okay, to determine if it's arithmetic or not, you want to see, does it have a common difference? Is the difference of two consecutive terms a constant? Okay, so in other words, 12 minus 7 is 5. Is 17 minus 12 5? Yes, and 22 subtracts 17 is 5, 27 subtract 22 is 5. All right, so this is our common difference. So yes, it is arithmetic, and the common difference is 5. Number 2, 5, 10, 20, 40, 80. Is there a common difference? 10 subtract 5 is 5. Is 20 subtract 10 the same? No. So no, this is not arithmetic. Number 3, 5, negative 2, negative 9, negative 16, negative 23, and so on. Is there a common difference here? Negative 2 subtract 5 is negative 7. Is negative 9 subtract negative 2 the same? Yes, it is. Does the same hold for negative 16 subtract negative 9? Yes, that also equals negative 7. As well as negative 23 subtract negative 16 is negative 7. So yes, this is arithmetic, and the common difference is negative 7. Writing a rule for an arithmetic sequence using the above formula. We want to write a rule for the nth term of the arithmetic sequence, and please simplify it. Then find a sub 10, the value of the 10th term. All right, so our formula is the one from above, which we need to memorize. A sub n is equal to a1 plus d times n minus 1. Right, memorize that. All right, well, what is our common difference, d? What does d equal? Well, 7 minus 1 is 6, so d is 6. 13 minus 7 is 6. And a1, our first term, is 1. So an equals 1 plus 6 times n minus 1. So we just plug a1 into our formula and d into our formula. And now simplify it. Distribute 6 over the parentheses. 1 plus 6n minus 6, and combine 1 minus 6 is going to be negative 5, so an equals 6n minus 5. So this is our rule. The nth term would equal 6n minus 5, and we also want to find a10. So our 10th term would equal 6 times 10, subtract 5, 60 subtract 5 is 55. All right, so two things we're doing here. We're finding the rule for the nth term using the formula, and then once we find our rule, we're plugging in to find the value of the 10th term. Next, let's find our d value. Common difference, 9 minus 2 is 7. 16 minus 9 is 7. Okay, common difference is 7. Write down the formula for an arithmetic sequence. an equals a1 plus d times n minus 1. a1, that's our first term, which is 2 in this case. 2 plus 7 times n minus 1. Distribute the 7. Combine like terms. So we have 7n minus 5. This is our rule. And now our 10th term, a sub 10, would equal 7 times 10, right? Replacing n with 10. That's 70 subtract 5 is 65. Number 6. What's our common difference? Negative 2 subtract negative 4. That's negative 2 plus 4, which is 2. 0 subtract negative 2 is 2. 2 subtract 0 is 2. Okay, so our common difference is 2. Write down our formula. an equals a1 plus d times n minus 1. So a sub n equals our first term is negative 4 for this arithmetic sequence. So replace a1 with negative 4, replacing d with 2. And now distribute and simplify. Negative 4 plus 2n minus 2, that's negative 6, and we have 2n minus 6. This is our rule. And now the 10th term in this sequence. Two times 10 is 20, subtract 6 is 14. Next, number 7. We have d is negative 4, a1 is 7. We're coming up with the rule. n equals a1 plus d times n minus 1. Now substitute in. a1 is 7, so replace a1 with 7, d with negative 4. Distribute the negative 4. That's negative 4n plus 4. 7 plus 4 is 11, so we can write this as 11 minus 4n, or it can be written as negative 4n plus 11. Both are acceptable. And our 10th term, 11 minus 4 times 10 is 40. 11 subtract 40 is negative 29. And we can always check these on the calculator. We can take our rule, plug it into y equals, and then look at the table of values. I'll show you that tomorrow in class. Okay, you can pause the video and do number 8 if you like. Again, just plugging into the formula. a1 is negative 9. Replacing d with 5. Distributing over the parentheses. Combining, we have 5n minus 14. And the 10th term will be 5 times 10, which is 50. Subtract the 14 is 36. We'll leave number 9 to do in class tomorrow. So on to page 4. Sometimes you are not given A1 or D, but any two non-consecutive terms. If this occurs, first you must find D. Next you must find A1. Then substitute them into the formula. To find D when two non-consecutive terms are given, let's call them A sub x and A sub z. Right? You can find D by taking the difference of A sub z minus A sub x divided by z minus x. Then to find A1, all right, if I go back to our formula and solve this for A1, okay, I simply subtract d times n minus 1. So if we take a sub n, subtract d times n minus 1, that'll get us A1. Okay, some examples to go through. Write the rule for the nth term of the arithmetic sequence, then find a sub 90, or the 90th term. All right, we have a sub 3 is equal to 12 and a sub 6 is equal to 21. So our d value we find by taking a sub 6, the higher number term, minus a sub 3, and dividing it by 6 minus 3. Well, a sub 6, our sixth term value is 21. Subtract our third term's value, 12, divided by 6 minus 3 is 3. 21 subtract 12 is 9, divided by 3 is 3. So our d value is 3. Now, a sub n equals a1 plus d times n minus 1. Going back to our formula that we need to know. Now you can choose, all right, you can choose either the third term to work with or the sixth term. It doesn't matter. Suppose I'm going to choose the third term to work with. All right, we need to find a1. Let me replace n with 3. So a sub 3 equals a1 plus, we found our value of d was 3. And we're replacing n with 3. The third term's value is 12. So 12 equals a1 plus, inside parentheses, 3 minus 1 is 2, times the 3 is 6. And now if I subtract 6 from both sides, we have a1 is equal to 12 minus 6 is 6. All right, we have a1. We know what a1 is. We know what d is. Now back to our formula again. And replacing a1 and d with their values and leaving n as the variable. So an equals 6 plus 3 times n minus 1. So we're coming up with our rule. Distribute the 3. And combining like terms, we have an equals 3n plus 3. This is our rule. So a sub n equals 3n plus 3. Quite a few steps, but not difficult. Just take it one at a time, one step at a time. Now find a sub 90. So the 90th term's value is, we're just substituting 90 in for n. 3 times 90, which is 270, plus 3 is going to be 273. Let's look at the next one. Number 2, we have the second term is 12 and the sixth term is 20. So to find d, we take the higher numbered term, all right, a6, a sub 6 minus a sub 2, and divide it by 6 minus 2. Well, the sixth term is 20. Subtract the second term, 12, divided by 6 minus 2 is 4. 20 subtract 12 is 8, divided by 4 is 2. So our D value is 2. All right. Let's go to our formula. A sub n equals A1 plus D times n minus 1. And we know the value of the second term and of the sixth term. It doesn't matter which one you choose. Suppose this time I choose the sixth term. So A sub 6 is equal to A1 plus D times, using 6 minus 1. Replace A sub 6 with the value of its term 20 equals A1 plus D is 2 and 6 minus 1 is 5. 2 times 5 is 10, so 20 equals A1 plus 10. Subtract 10 from both sides and A1 is 10. So our first term is 10, right? We need to know D and our first term in order to come up with our rule. So back to the formula, A sub n equals A1 plus D times n minus 1. Keeping n as a variable here, replacing A1 with its value, D with its value of 2. Okay. Distribute the 2 over the parentheses. Combine, 10 subtract 2 is 8, so this would be 2n plus 8. So this is our rule. A sub n equals 2n plus 8. And then the 90th term, 2 times 90 is 180 plus 8 is 188. All right, so our rule was the nth term is equal to 2n plus 8. So if we want the 100th term, we would simply replace n with 100. That would be 2 times 100 is 200 plus 8 would be 208. Number 3, again, you can pause the video if you like and try it on your own. We're given the 4th term and the 7th term to find D. We're taking the higher number term, the 7th term, subtract the 4th, and dividing it by 7 minus 4. 40 minus 7 divided by 3. That's negative 30 divided by 3 is negative 10. So our D value is negative 10. Let's go to our formula. A sub n equals A1 plus D times n minus 1. I'll choose the 4th term, 70. A sub 4 equals A1 plus D times 4 minus 1. Our 4th term's value is 70 equals A1 plus D is negative 10. 4 minus 1 is 3. So this is negative 30. So 70 equals A1 plus negative 30. If I add 30 to both sides, we have that A1 is equal to 100. Right? Adding 30 to both sides, not showing that step. So we have our first term is 100. Back to our formula. AN equals A1 is 100. Our D value is negative 10 times n minus 1. A sub n equals 100 plus negative 10 times n is negative 10n. Negative 10 times negative 1 is positive 10. Combining like terms, AN equals, we can write it as 110 subtract 10n, or you may write it as negative 10n plus 110. All right, but this is our rule. And now we want the 90th term. So A sub 90 would equal 110 minus 10 times 9. So 110 minus 90. Oops, excuse me. That's 10 times 90, which is negative 900. 110 minus 900 is negative 790. Okay, and we'll leave number 4 for tomorrow in class. So this concludes tonight's video.